Trees. We're talking about binary trees, not this one. It is something more similar to family trees and this kind of tree. So we're gonna deal with something that looks like this. So, what are you going to expect in this video? First of which is the terms about binary trees, and second is binary tree traversal in Java. All of which are going to have visual explanations, so you're going to be able to see exactly what is going on. So let us go for the first topic we're going to do. Terms in binary trees. Let's look at the node. A node is an element of a tree that could contain data or a reference to a child node. This means that a node can contain a data type. It could be a string, it could be an integer, it could be a double, it could also be a boolean. And a reference essentially means a link to a specific node within a tree. Let's go with the next term. Root. It is the topmost node of the tree. It is the highest part of a tree. Another term you may encounter is parent. Parent has one or two child nodes. Next, a child node. It is a node or nodes below the parent node. So, let us now see what these terms are within an actual binary tree. Right, so now that we're here, we're simply going to recall the definitions that we did earlier. So, this is an example of a node. This, that, this one, that one, and this one are all examples of nodes. Why? Because they have a data type within them, an integer to be precise. So, a node also references child nodes. So, this node that has a value of 1 is a parent node and a root node at the same time. It is a parent because it has two children, 2 and 3. And it is the root node because it is the topmost node among this tree. So knowing all this, I believe you would pretty much already have enough understanding to understand what's about to go on in actual code. Let's get to a code editor. Now, in Java, you would usually see a class like this to represent a binary tree. It is called a node that has stuff called int data, node left, node right, and also a constructor that is node and contains a parameter of data. They usually have these values, but essentially these are controls in order for you to be able to insert values to a tree. I think it's way better to explain it in actual code. So I'll go to the main.java file right now and go and create some code. So basically, you start with something usual, like public, static, void, main, string, args, and then you go and begin to create the actual tree itself. So the first thing you got to do is create the object of the node class. I'll call it root. Let's do new node, and then we're gonna add a value, an integer to be precise. So let's go add 1. So essentially this is me creating a root node. Let's visualize it. What you essentially did is something like this. 1. Behold my creativity. Now, if you do want to add another piece of data, let's say for example you want to add a child to the left side of the root, you will simply do root dot left equals new node. And then you add 2, for example. So now it would look something like this. Bam. Circle 2. Wonderful. Now if you do want to add another node to the right side, you would do something like this. Root dot right equals new node. And for example, you could add tree in it. There you go. And now for the beautiful visualization. Weep. 3. Absolute masterpiece. Now, what if you want to add another value to the left of the left node? You do something like this. Root, starting from the root, dot left, and then you go to equals new node, and you want to add the value of it. Let's go. Whoop. Weep. 4. There you go. Now if you want to add something to the right side of the left node that we just did previously, you do something like this. Root dot left dot right equals new node. Then we hit another data, 5. Now it looks like this. Boop. 5. Amazing. Hopefully you understand now how exactly are you going to create a binary tree. So how are we supposed to traverse this kind of tree now? That's what we're going to discuss next. So here are 3 different ways to traverse binary trees. Those are pre-order, in-order, and post-order. In pre-order, the pattern is root, left, right. In order, it is left, root, right. In post-order, it is left, right, root. So right here in our main code, I simply added these 2 lines, and it looks something like this. And yes, it is exactly as the first binary tree example in the video. I just simply added 6 and 7 over here because I'm pretty sure you don't want to look at that same masterpiece I created. So let us talk about the in order traversal. So how does in order traversal work? So here's one simple tip that I can give you in order for you to find out the order of how we traverse this entire tree. Look at the farthest left node, and it works every time. You have to mark it like this. What is the farthest left node here? You can see it's 4, right? So mark it as 1. Now, excluding 4, what is the farthest left node here? That's right, it's 2. Now, what is the farthest left node here left? It's 5. The same logic goes on. What is now the farthest left, excluding everything we've marked? That's right, 1. So now we mark this as 4. But here, what is the farthest left node here? It is not 3, it is 6, since it is the farthest left. 5. And if we continue with that logic, this is 6, and this is 7. That is in order traversal. Now that we're back, what we did was create a recursive method called in order traversal. Its base case looks like this, and what it essentially does is look for the leftmost node, and then we go back to the root, and then it goes through the right nodes. And in order for us to see what the output is, I did these 3 lines of code. So let's show it. So just as we discussed, it prints out just as we ordered it in the illustration earlier. 4251637. Let's talk about post-order traversal. What does it look like this time around? It goes like this: left, right, root. We're not gonna go here yet. We're gonna go look again at the second part. Left, right, root. And then lastly, we go back to the root. This is what post-order traversal looks like. Now we're back. Just like the other example, post-order traversal looks something like this. There we go. Just like what we discussed earlier, the order was 4, 5, 2, 6, 7, 3, and 1. What does pre-order traversal look like? So, we first go to the root, which is 1, then we go all left. So 2, 3, and then we go right, 4. Now there is nothing here on this side, so let's go to the other side. This is now going to be 5, 6, and then 7. This is what pre-order traversal looks like. Going back to our code editor, pre-order traversal looks like this. There we go. Just like we discussed once more, pre-order traversal looks like this. 1, 2, 4, 5, 3, 6, 7. That is pretty much all for my video. And man, massive thanks to my goat BroCode. I couldn't have made this video without him. And I pretty much took plenty of inspiration from him in the creation of this video. So please consider liking and this video and also subscribing to his channel. Thank you. And this video was dedicated to my fellow college students out there studying DSA, and also to whoever finds this content remotely interesting. Thank you for watching this video, and if you do have the time, please consider liking and subscribing. And please also do comment if you have any sort of suggestions for next videos, any sort of things to improve on. Please do. I'll read your comments. That's all. Ruko-san out.